Hello, everybody. Welcome to another wonderful chemistry class. And we have a few things to learn today, as you can see. It's going to be a great class. And with that in mind, here's what we're going to be talking about. The overarching question is, what is chemistry? And this particular lecture's focus is going to be, what are the branches of chemistry? So the new vocabulary that you may not have heard before is going to be chemistry, organic chemistry, inorganic chemistry, biochemistry, analytical chemistry or analytic chemistry, applied chemistry, and that's the last new vocabulary. So with all that out of the way, let's get into it. So chemistry is basically the study of matter, which is the stuff that the universe is made of. So it's the study of the composition and changes that occur within matter, or that matter undergoes. And matter is anything that has mass and occupies space. So you, the lab equipment, the air you're breathing, all matter, all has mass, all occupies space, and in a sense is all part of the study of chemistry. So first off, what is organic chemistry? Well, this is the chemistry of matter containing carbon. It used to be synonymous with biochemistry, but kind of became its own thing because there are things that contain carbon, in fact, a lot of things that contain carbon, that are not actually alive, so they are not biochemistry, even though organic and biochemistry overlap quite a bit. So organic chemistry is the study of things that contain carbon. Now, in contrast, inorganic chemistry is the chemistry of matter that does not contain carbon. And you might think to yourself, why are they separating based on carbon and not carbon? And that's a fair question. And the reality is that carbon is a really special molecule. You can make a nearly endless number of compounds, different things, with just carbon and all of the different elements that are bonded to it. So having its own branch, special branch of chemistry is important because it's truly unique. And we'll talk more about that later in the class. Now, your inorganic chemistry includes things like metallurgy, things like, oh gosh, metallurgy is the best example that I can think of off the top of my head. But it's the idea that anything that doesn't have carbon is what's being studied. So different materials, different types of alloys, different types of ceramics, that's the word I was looking for. All of these things don't contain carbon and therefore are inorganic chemistry. Glass is silica, not carbon, and that would be inorganic chemistry. Why does it have different colors? That's inorganic chemistry. So lots of room for that, and it's good that it has its own category because the majority of the elements are metals of some kind or another, and we'll look at that later. Now, the last one in this particular little montage is the biochemistry. And here I have a little DNA molecule. I think it's a pretty fancy DNA molecule, but the chemistry of life and organic chemistry, they used to be thought of as the same, analogous to each other, because we were only able to get carbon type reactions in biological systems. And so, but in modern times, biochemistry and organic chemistry have kind of separated out, where biochemistry, even though it deals with carbon, because all of life is based on carbon, it deals specifically with the chemistry of life, which is in and of itself very sophisticated. And because I wanted to understand biology better, that's actually why I took so much chemistry. Now, analytic chemistry is the kind of the measurements of a new type of matter. So if you create a new element or you find a new element, it's going to be focusing on analyzing that element. It's going to be analyzing different aspects of the matter itself. What are the physical and chemical properties, which we'll talk about later. That would all be analytic chemistry. And then applied chemistry, I have this rocket launching here, is the chemistry that is useful to humans. And that pulls from other branches of chemistry, right? Because biochemistry can be really useful for humans. Inorganic chemistry can be really useful for humans. The combustion fuel in these rockets are oftentimes not necessarily carbon-based. And so that's inorganic chemistry that's being applied. So anywhere you take chemistry and you make it useful for humans outside of just studying it for the sake of studying it, that is applied chemistry. So, what are the branches of chemistry? Well, you've got organic and you've got inorganic. You've got bio, you've got applied, and you've got analytic, right? So those are all the different branches of chemistry. And I hope this was informative. I hope you learned something. And I hope you think of good questions from this, because there's a lot more to know than I just presented. So thanks for listening. I've got questions for you, and there'll be another lecture in this this line or this assignment pretty quick. So thanks for listening.